Hello ladies and gentlemen, this is Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled Planet X is Here, Irrefutable Evidence, Further Discussion. Now in article 105, I showed the image shown again here in figure 1, and it's a soft X-ray image from the Yoko satellite of an object eclipsing the sun. The image is of enough resolution to see the contours on the object. As you can see, it almost looks like there's a line here, and there are curved contours along here, and it looks like there's a raised sheet of material raised above the rest of the surface of the object. So we can actually see contours that gives us an idea of what this object is shaped like and some features on its surface. And so this has to be quite a high resolution image for us to be able to see those kind of features. And we can even see that the right hemisphere of the object is brighter than the left hemisphere. And these contours are mainly around the equator of the object on the left hemisphere. So the object seems to be clearly emitting X-rays, and this is what I said in article 105. And the fact that it's a high resolution image and it is emitting X-rays means to me that it's a Planet X object, and one of these objects that have invaded the solar system and have congregated in the sun's corona that I have been writing about for quite some months. And there you will find more details on these objects in article 93, Planet X objects in the sun's corona. There are several images where we can see these objects in the sun's corona. Now these objects make magnetic connections with the sun. They interact with the sun through their magnetic field, and they actually reveal a lot of detail about the sun's structure, and that is available in another one of my articles. Specifically on what they reveal about the sun, and the fact that it's not actually a gaseous object. It is made out of solid and liquid material. Now, certain people have determinedly claimed that this object below is the moon, as the moon emits soft X-rays. Now, let's look at this image again. As you can see, there's the object, and as far as I can see, you can literally see X-rays being emitted from different parts of the surface of the object, to the point that we can determine details about the surface. But this is not the only object in this image. There is clearly a circular outline that indicates the presence of another one of these objects further back, and actually in the sun's corona, because you can see some coronal plasma coming in front of it. And this one is partly covered on one side with plasma, and as you can see, it's got a dark surface similar to this one on that side, a darker surface, but there's still X-rays, soft X-rays being emitted from it. Now, the moon does not emit X-rays. The moon is simply not hot enough to emit X-rays. Only stars can emit X-rays. But the moon does emit some, very few, but some soft X-rays as a result of scattering. And these are so few that they're only visible in very long exposure images. So you can see one such image from 1990 here, where you can see that the dark side of the moon is emitting some soft X-rays, and there are more on the bright side of the moon. Now, let's not forget that what we are seeing here, if it was the moon, would be the dark side of the moon, because the sun would be behind it. This would be the side of the moon that would not be receiving any light from the sun. So it would be more like this. However, this is a long exposure image, and we can see that from here. This is that particular image shown again here in this different format. But we told the length of the exposure. It's 1,899 seconds, which is actually 31 minutes and 39 seconds. So this is an extremely long exposure. It takes over 30 minutes for these many dots of X-rays to be detected, whilst the images from the Yoko satellites, such as this one, have a very short exposure of the scale of the time of the exposure is about 1 second. So 1 second compared with 1,889 seconds, that should tell you that images that the Yoko satellite detects should show that the moon is basically black, because there are so few X-rays emitted from the dark side of the moon. If it's a short exposure, there wouldn't be any. So as we can see, these are actually images of real lunar eclipses. And as you can see, this is a Yoko satellite image in soft or low energy X-rays. And you can see that this is the moon, and there are just a few X-rays detected along the edge of the image. There are none being emitted from this side, and obviously this is the side that would still be getting some sunlight from the sun, perhaps, and we can see a larger portion of the sun in this image, much larger than what we saw in figure 1. There's only a tiny portion of the sun here. So this is what the moon would look like in some of these images. And this one seems to be even lower resolution than the one shown in figure 1. This one is from the Hinode satellite, which replaced the Yoko satellite. As you can see, the moon looks completely black here, because this is a short exposure and no X-rays at all were detected coming from the dark side of the moon, as we should expect, because this is typically a 1 second exposure, and so no X-rays were detected at all, because there are so few X-rays emitted by the dark side of the moon. So we cannot expect this object to be the moon, because if it was the moon, this object would look completely black, or almost completely black, at least like this one, but probably more like that one. And in fact, we can see it's a very high resolution image, because we can see so many details about the surface of the object, several contours, and we can see the fact that this side of this object is brighter than that side. But it is on this side that there is great illumination coming from the sun. So if this was the side that was getting more sunlight, we would expect this side to be brighter than that side, and it is the other way around. So this again shows that this cannot be the moon. This is an object that is actually emitting X-rays, and it's emitting so many X-rays that we can see contours and features on its surface. So as I said, notice that the moon always emits more X-rays on the side that is illuminated by the sun, but in this image, the left side is expected to be brighter, but it's actually darker. Now, this is actually an indication that X-rays seem to be coming off this object, or emitted X-rays, not scattered X-rays. And an object which emits X-rays has to be hot enough to accelerate electrons to high velocities and has to therefore be a star. And I explained this in article 105. So this object cannot be the moon or a planet, as these objects are never hot enough to emit X-rays. And in fact, it shows that the object is actually rejuvenating like one of the oldest stellar cores, and of which we see an image here. This is the blue stellar core, which was photographed by Scott and then someone else from Germany. And you can see it's got a solid core, very little ionizing material left. It was shedding this material. And it is in the sun's corona. It's making magnetic connections through which it's drawing plasma, which is collecting here underneath the object. So this object seems to be one of these. So in conclusion, the Yoko image shown in figure 1 provides irrefutable evidence that Planet X objects or stellar cores, in other words, old stars that have gone through the red giant and white dwarf phases and have lost most of their ionizing material to the point that the cores of these stars have become exposed, like this one, are in the inner solar system and the sun's corona. And the fact that some regions on the object's surface are brighter than others indicates that the object is going, or was at the time, it was actually from 2001, through the typical rejuvenation process of gaining ionizing material, like this one is here, from the sun, and also an increasing ability to emit light from the core, which spreads from one initial brighter region on its surface, as detailed in my article 100, Planet X Objects, the rejuvenation process. And you can see on this object that there's a region on its surface that is brighter, that is lighter blue than the rest. So this seems to be where the object is brightest. And then this brightness, and thus the ability to emit light from the core itself, seems to spread from the brightest region further outwards. So, and therefore this stellar core, the one seen in figure 1, is likely to be one of the oldest stellar cores that have invaded the solar system, and thus similar to the blue stellar core which is shown in this figure. And here are my references. These ones are all from my own articles, which explain some more details about what I talk about in this article. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.